Assalamualaikum and hello everyone. So today I will give some explanation on how I and my friends solve the question on our task assignment. Firstly, for the question 1, the question asks us to sketch the free body diagram and the kinetic diagram of the object. So, in the figure 1, it states that the object is on the slide. So, we will have the normal force that acts perpendicular with the slide surface. Next, we will have the weight force that also acts on the object. And lastly, we will have the force that is act on the object. That is because the object is sliding down from the slide to the ground. Next, we need to sketch the kinetic diagram. But first, the kinetic diagram is the diagram that shows us which direction and magnitude of the object that move and have acceleration. So, to sketch the kinetic diagram of the object, we need to sketch the direction of the arrow that is going down through the slide, because we know that the object have the acceleration and move in that direction. Next, for question 1b, we will use the kinetic force and potential force formula, that is 1/2 mv square and mgh. So, with both formula, we will solve the equation using the concept of energy. That is, energy cannot be created or destroyed, but it can transform. So, we know that on figure 1, the question state that the object is rest on top of the slide on 3.5 meter height. So there it will have, or the object will have, the potential energy, and at the last of the object before it leave the surface B, the object is moving, so it will have the kinetic energy, and we can know the velocity of the object when we solve the equation. So, using all the data and information given, we can put it into the equation we made, and then we can solve and get the final velocity of the object before it leave the surface B is 7.0036 meter per second.
Okay, I will continue for question number 2. Question number 2 state that the object from part 1 release from rest and slide down along the smooth ramp as shown in figure 2. Assume y0 is 1 if y0 is 0 in part 1. The horizontal velocity, which is v1, is equivalent to the speed of the object just before it leaves the surface of B. Take the coefficient of restitution, which is E is 0.7. Question number A is calculate the velocity of the object just after it rebound from the ground. So the question wants us to find at this side. So the first step is we can use the formula V square equal to V0 square plus 2AC open bracket S minus S0 close bracket. So we elaborate it to VCY square equal to V1 square V1Y square plus 2AC open bracket SC minus SY naught close bracket. And then we insert the value into the formula to get the VCY value, and then we get the VCY value is negative 4.4294 meter per second. The second step is we use the coefficient of restitution formula. So we create it as a E equal to VG2 minus VCY2 over VCY1 minus VG1. And then we insert the value to find the VCY2, and then we get 3.1006 meter per second, which is upward. The final step is we find the VCS. So we use the formula M open bracket V1S close bracket equal to M open bracket VCS close bracket. So we get the VCS is 7.0036. And then for the velocity of the object just after it rebound from the ground, which is VC2, we got it 7.6593 meter per second. So we proceed to question B. The question B is compute the maximum height to which the object rises after the first bounce. So this means we need to find the h in the figure 2. As we know, the V2y, the value is 0 because it doesn't exist. So 0 equal to 3.006 square plus 2 open bracket negative 9.81 close bracket open bracket h minus 0 close bracket. So we get the h value is 0.49 meter.